Hello everyone, my name is Nikita and I am from the Bodhi Academy. In the last video, we had covered the concept of Ohm's law in the chapter Electricity of 10th Standard Science textbook. Today we will be covering the next concept, and the next concept in this chapter is something called as the combination of resistors, in which combination we can combine the resistors. So comparing the combination, we have two combination. First one is the series combination and the second one is the parallel combination. Combination of resistors, in that we have something called as the series combination and the parallel combination. Okay, now what is a resistor? A resistor is something which carries resistance, and we have already studied what is resistance. It is the ability of the conductor to stop the flow or to resist the flow of the charges. So the resistors contain this property called, give this property called as the resistance, and these resistors can be combined in two fashions, that is two arrangements, in series combination and in parallel combination. So now let us first see what is series combination. Resistors in series. When we have resistors in series, we connect the resistors end to end. So resistors in series, in that the resistors are connected end to end. Okay, so they are connected from one end to the other. So this is my first resistor. This is the second resistor, and now I will be drawing the third resistor. So now these resistors have different values of resistances, so I will name them as R1, R2 and R3. Okay, now we will complete this circuit. Okay. So in the circuit, first we have the battery, the key, okay. Here we will connect our ammeter. Okay. This is the positive end and this is the negative end. This is the flow of the current, and here in parallel we have the voltmeter. Okay, this is the positive and this is the negative end. Now the resistors over here are connected end to end. Okay, now what we need to learn next in this is the concepts of potential difference and current over here. So in this arrangement, in series arrangement, the current in all the three resistors 1, 2 and 3, the current remains the same and it is I. But V, okay, V, that is the potential difference, it differs. We have V1 for resistors 1, then we have V2 for R2 and we have V3 for R3. Okay, now if I have to apply Ohm's law, okay, what is Ohm's law? We have studied that Ohm's law is V equals to I R. Okay, now this V is the total V. The total V means V1 plus V2 plus V3. So total V is equals to V1 plus V2 plus V3. Okay, now the Ohm's law for each of these potential difference will become as V equals to I R1, V1 equals to I R1, V2 is equals to I R2 and V3 is equals to IR3. Now I'm applying Ohm's law for all this. Okay. Now, looking at this equation, I will combine all this V1, V2, V3. Okay. So after getting that, V equals to IR1 plus IR2 plus IR3. Now what is same over here? I is common. So I will take I out. And in the inside we'll have R1 plus R2 plus R3. And we know from Ohm's law that V equals to IR. So here also we'll write IR. Okay. Now I is common on both the sides. So I will cancel out. Now we will have R equals to R1 plus R2 plus R3. So in series connection, resistors in series, the resistors are joined end to end and the total resistances is the sum of each individual resistors. Okay, the total resistance in series is equal to the sum of the each resistors. So what do we need to pay much attention over here is first point that the resistors are connected end to end. Okay. Second point, the current is the same. Third point, the potential difference is V1, V2 and V3 respectively for R1, R2 and R3. Then we say that the potential difference, total potential difference, the sum of all potential differences. Then we see what is V1. V1 is IR1. Then we see what is V2, IR2. Then V3, IR3. Then we combine this in this main formula. Okay, in the main formula, and after combining we get IR equals to I R1 plus R2 plus R3. I is common on both the sides, so it gets cancelled out, and finally we get RS, resistors in series, is equals to the sum of all the resistances in the connection. Okay, this was all about resistors in series. One important point we need to mention here, I need to mention to you here, is that the current in the entire circuit, in all the resistors, is the same. Here the different is the potential difference. Okay. Now we will move on to the next combination, that is resistors in parallel. What will be the difference in resistors in parallel? First of all, we will draw the diagram. Now, in resistors in series, the resistors were connected end to end, one end to the other end. Here, the resistors are connected one above the other, means parallel to each other. Okay, means the first resistors okay, this is the second resistor, this is the third resistor. So again we name them as R1, R2 and R3. Okay, then we will complete this circuit diagram. First the battery, key, okay, then we have the ammeter, okay. Then we have the voltmeter. Okay, so now first is the connection. Here the resistors are connected parallel to each other. Now the second concept which we have studied is what to determine what is I and V, how it is different. So here what is same is the potential difference. Okay, the potential difference is same and I is different, means it is I1, I2 and I3. So again we are applying Ohm's law, V equals to IR. Okay, now we need to find the total current. We know that V will be same. Now what will happen to the current? The current will be I equals to I1 plus I2 plus I3. Okay, now we need to put this Ohm's law as I equals to. So if I put it as I equals to, it will be I equals to V upon R. Okay, so now this equation is I equals to. So I will continue with this. So I equals to V upon R, correct, is equals to, now what will be I1 will be V upon R1 plus I2 will be V upon R2 and I3 will be V upon R3. Okay, now we need to again see what is common in all these three. Common is the V, so I put V separately, and then what will remain inside is 1 upon R1 plus 1 upon R2 plus 1 upon R3, which is, this will be V upon R. Now V is common on both the sides, so V will get cancelled out. V gets cancelled out and this will be 1 upon R, which is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Okay, so series connection is opposite to parallel connection. Okay, in a series we have the current is same. In the parallel connection we have potential differences same. So we need to see some points over here. First of all, the connection, the resistors are connected from one to another, okay, one parallel to the other. Okay, secondly, the potential difference is the same. Third point, the current differs as I1, I2 and I3. Then we have to apply Ohm's law over here. Ohm's law we do this time is it as I equals to V upon R in that form. Then we see what is total I. Total I is I1 plus I2 plus I3. Then we just substitute the values and the final we get is 1 upon Rp equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So what will be the definition of resistors in parallel? The resistors in parallel is equals to the sum of the reciprocal of the individual resistances. Resistors in parallel connection means it is the sum of the reciprocal of the individual resistances. Okay, now the most important thing is over here is the current. Now it is said that it is impractical to connect two gadgets, okay, two gadgets which require two different types of currents to operate properly in series connection. Why is it so? This is because in series connection the current, okay, the resistors are connected to end and the current through the entire circuit through all the resistors is the same. So if we connect it in series connection, the current will be same and they won't be able to operate properly. That's the reason it is practical to connect them in parallel, in which each resistors have separate current. Okay, there is separate current and the current will get divided properly. Okay, this is the most important question asked over here. The next question which is asked is the differentiation to differentiate between resistors in series and resistors in parallel. So the first point of difference will be, in series connection they are connected end to end. In parallel connection they are connected parallel to each other. The second difference is, in series connection the current is the same. Okay, the current is the same. In parallel connection the current is different. Current is different as I1, I2, R3. Then we talk about potential difference. In series connection, the potential difference is V1, V2, V3. And in parallel connection, the potential difference in the entire circuit is the same. And the final point will be, in parallel connection, the total resistance is equal to the sum of the individual resistances. Okay, and in parallel connection the third point would be, the total resistance is equal to the sum of the reciprocal of each individual resistors. Okay, this is all what we need to know about resistors in series and parallel. The most important thing we need to know about is the formula. Okay, RS. For resistors it is Rs, which is equals to R1 plus R2 plus R3. Then the next, in parallel it is 1 upon Rp, which is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. These are, and the derivations are very simple and they are very important also. The circuit diagram is also very important. In the next video we will discuss the numericals based on this, and we will also solve some numericals based on this concept. Yes, so thank you for watching my video. Please share, subscribe and like my video.